Boom. Okay. So, welcome. This will be a very informal session in which you are free to just ask whatever you like, whatever you need to know. I guess we just a bit of time to go through the system together so that you can have a better, more detailed picture of the engine. Sebastian is here as well. Nice camera. With this new laptop. Okay. So lab. Okay. First of all, if you are in a silent place, please unmute your microphone. I'd like to hear a bit of, at least a bit of noise of something. Otherwise, I feel like the void is. I can't breathe. So yeah. First of all, did you have the chance to look at the video at the Node workshop about that Sebastian did about the architecture and building system? Because in there, the last part, I did a small overview of the entity component system. So, and that was ideal, no? If you have a clue about entity component system. And Sebastian posted this, the link to it in the Elementa chat as well. But I don't know, did you see it or?
Yeah.
Yeah.
Okay, Niels didn't see it.
No.
Alex?
I was there.
Yeah, yeah, sure, you are in the same.
You were a moderator.
Yes. No cam, no mic. Okay. Cool. So, well, okay, I'll give a bit. I will go through very, very quickly. Let's open. Would be nice to have that patch. Sebastian, do you have it around?
Which Sebastian?
Greg's. Sorry.
Wait, okay, and which patch?
The element, the entity component patch of your workshop. No.
I can try to find it. No, right now I don't have it. But
yeah, let me check.
You think we should start from that implementation side, or I mean, that's the main question. No, do you start from the user perspective or from the the developer perspective?
No, I would. This talk, it was about developing stuff, so I don't want to really start. Okay, this is a widget. This is we play with it. I give granted that you all played a bit with Elementa. Otherwise, yeah, there's no time to really.
Yeah. But I'm not sure if I, for example, know all the features.
No. I will talk about the features, okay, but not from the very basic things.
No. But I think it's also important to have a general understanding what you want to achieve before you think about modifications of the system or.
No,
yeah.
indeed, of course.
The
That's all about
of the system should be based on.
That's all about it.
Achieve. But
yes,
yeah.
yes.
Anyways, I can try to find that document in the meantime.
I just see it on your GitHub repository. Rexon / built-in systems workshop. You uploaded there.
But wait, because I sent you exactly that patch, right? This one, what is that? No, where was it?
I think I have it here.
Ah, yes, I also have it here, I
This one.
think.
Yeah, exactly.
Let me just try to open it, because there was a very stupid, simple example, so that we can be fast. Oh, yes. Okay. Yes. Okay. Entity component. It's a programming pattern to create systems, and it consists of there are these two main things, which is one is the entity, and the entity is supposed to represent something, an object of our system, and then there are components which are extensions of they are capabilities, they are features that you can use and plug into your entity to extend its features. So this is the main principle. This is how you build and describe the properties of your system. So the basic idea is that you have two interfaces, iEntity and iComponent, so that you can create your own data type. In this case, it was a class called entity. And this class implements iEntity, so it's identifiable as an iEntity. Then you can create classes which implement iComponent interface, so that these classes will be recognized as components in our architecture, and so you will be able to use them as features for the entity. And so yeah, this entity is very, very basic. As you see, it can have children, which are other entities, and has components, so which are the features that you can extend the feature of the entity. So in this case, this first object that we plugged here doesn't have any children, is a leaf. But we added a couple of components. This is bounds component, and each component has its own, it's a completely independent class that can have its own properties and functionalities. So you just need to implement iComponent and the operations of the interface in order that we can indirectly operate on it through the interface. But apart from that, they are completely independent classes with different properties. And we simply can connect them to the entity to extend the capabilities. Then here, for example, we use a cons with another entity, and then the spread of entities, we feed it into another entity, so in the children of this entity. So this is already a tree, okay? It's a graph, it's a tree. And then we do it again, same thing, cons with another entity, which has some components. And then we fit it into another entity here, which is the main entity at the end of the first entity of the graph of the tree. This is a tree, as you see. This final entity, we fit it into the root. And the root is where the magic happens, no? Where we really make use of the components, and we operate into the system. And we will see how. So the idea really is that the entity itself is really a concept. It's not much that an idea, a Platonic idea. Okay, I've got this table. It's just the concept of the table, no? But then all the properties of this table, like the mass, or I don't know if it's draggable or whatever, they are provided by the components. So that the entity, and you will see also in Elementa, the entity is supposed to be very, very simple, essential, stupid. It's simply, it's an entry point to access certain features, certain components, and access the rest of the graph. But itself, it doesn't do anything, just it's very stupid. And then there are the components. And the idea is that the entity, as I said, it's hosting the components. And in this example, we have 3 components. One of them is over component, because we wanna have this feature that if I hover with the mouse my object, I got information if I'm over it or not. So, and that's why we have this over component that just take care of giving me that information. In fact, if you look inside, this is part of the interface operations of iComponent. So it's not specific to this one. What simply has this component is a property which is a Boolean. So it's data, pure data, where I can simply store a Boolean that says, okay, I'm over or not. And as you see, nothing really happens here. I got just the possibility to write the information there and read it from there. But the component is super basic. It's just hosting data. But that's why then we have an over component processor. And the processor is where we really do something with the components. So the components are sort of flags that I put everywhere, or just data that I put there that I can operate with, and I can write into them. And the component processor is the one that takes care of dealing with over components and manipulating them and writing into their properties. And in this case, if we go inside, as you see here, this component processor is filtering by type the components that are in the system. And somehow we will see also in Elementa, is retrieving the other components, the bounds component, because you need to do a heat test, you know, if you want to know if it's over or not. So here is retrieving the other component, doing a heat test, and then writing the result into the component property. I need to wait. How do I do it? Sebescuit is locked outside.
It's in participants.
Ah, yes, found it. I think he should be able to join.
Yes.
Okay.
Sorry.
Yes, so this is a very basic example, but just to show you how it works. From the component processor, we write back, we evaluate our stuff and compute things and write back into the components, just the final data. And as you would expect, all the component processor, this processes happen in the root. So in the root is where we collect all the children, all the elements of our graph and operate on them, calling some component processors. So this is somehow simple overview about the entity component system. Now, yeah, I think, yeah, we can switch to Elementa and you will see that it's somehow it's not different. Let me check. We can simply open the widget in action. There we go. So, yeah, this is one of the add patches of the Elementa library, and or maybe I could just patch it, simple one, and let me patch it. I don't want to do exactly the same. So new patch, I'm going to reference Elementa. And then I can have toggle. So first thing is that in the Elementa library, the entity interface is called I.Elementum from Latin. So that's the interface that represents our entity, you know. And then we've got I component for the components. So this toggle, for example, it's an Elementa entity. Well, this is already a wrapper around it, but this one, it implements I.Elementum. So it's in the other patch, it was I entity. So I.Elementum is our container that we can extend with components. And here you see that there are some operations which are probably from interface that I can show you. Where is it? Okay, so this is the entity interface of Elementa. As you see, it's very simple. Just has some common features that we want to have in every widget so that we can make use of the system. We'll go back to here. And then we've got components. This, what? Come on, leave me alone. This entity, this Elementum has a property which is components. It's a dictionary of components. So this would be the extensions of our Elementum. And in this case, this toggle on create already have some components because we know exactly what is the toggle, what it's supposed to do. So we need that component, that component, that component. And this is exactly what we're doing here. We know that we've got a numeric value, which is the property, the value of our toggle that we want to operate on. So this component holds that number, that property that we can operate on. Then we know that this toggle must be overable, must be layoutable. So we got this layoutable leaf component, which means that we have position, size, so that it can be part of a layout. Then we got stylable because we want to have a style. Default toggle drawer is what really draw in the end. Given this bounds, I want to draw my toggle in a certain way. And this is the default drawer for the toggle, which simply draw the button, okay? behavior, it's the logic, how we interact with the widget. We'll go back to here. And attributable is just a way, to add feature, to add attributes to your widget. So what happens is on create, these components get provided as a spread of components, and then there is this utility node that takes care of building the final dictionary of components. So if you see that, so these are the internal components that are part of the toggle, but then there is also this components pin, which is it's a spread of components, because the concept is that, okay, we want to have widgets which come, as we said, they are entities and they are elementum, okay, interface, but they already have some components inside. So we must provide these components on startup, on create, but then eventually we might want to add new component to extend new components in the patch. So that, for example, if we are here, we can, I don't know, we can put transformation. No. What's the name of the component?
Transformation. It's transformation.
Transformation.
Yeah.
Yes. So this is a component. And now selecting this is our widget, we can Ctrl+ and a new component appears, so we can extend. So then it's all about combining, merging somehow the internal components with the one that we provide from outside. And this is why we got on create a spread of components here, and then on update, we got another input here that takes the component from the patch outside. And this guy, whenever the external spread changes, so which means that we add a component or remove a component, then it takes care of merging them together and into a unique dictionary of components. There is also this versioning system, which takes care of giving the information side about, okay, if something changed in the components. So whenever something changes here, the new list of components gets computed, then the version will get increased, and so that from outside, this widget can provide an information. Anyone can ask, okay, can check, can take the component versions of this toggle, and if it changes, it can do something with it. And we will see that this is important in the root, because we don't want constantly to check all the components everywhere to get all the widgets, all the entities, get all the components. There must be a way, a system, so that just when we change something, then this information get propagated, and the root reacts to it and maybe recompute certain things. So this is the one way to do it. Just, okay.
Only the components have a version. The entity itself is so slim, and everything that moved to components that you don't need a version for the entity itself. Just a version for the components is enough.
Yes, because in the end, then you can abstract and get information. Like each component can have its own, introduce its own version, somehow versioning system, like the layoutable components. I don't know, they can check, the layout can check if some of the layout component changed. and then react to it. But these are somehow, yeah, independent channels, no, that each component introduce. But yeah, what the entity provides is just information. Okay, these are my components. This is the version of this current set of components. If something get removed, added, then there's a new version. So you might be interested in react to it.
I was just wondering if the entity itself has a property that can change, and then you want to.
The audio is very bad on your MacBook Pro. But it wasn't like that before. You just install the driver on the fly. It was better before.
Yeah, so it's the same thing. The audio is bad. I'll shut up.
I have a little question. I see that all your operations in this class are marked internal. What this stands for?
Sorry. This one, you mean?
Yeah.
Yeah, they are marked internal because this was an attempt to clean up a bit the Node browser. Okay, because you can imagine if you got all these operations and they appear in the Node browser, you will have, I don't know, thousands of operations, and it's just getting messy to navigate the Node browser. So this is one way to hide the operations from the Node browser. It's a workaround, I would say. But since in VL we don't have a nice way to define what will show up or not, that was, yeah. And also because many of them, you're not really interested to talk that, let's say, for example, these are operations that clearly come, they are part of the interface, okay, of the VL.Elementa interface. So you are not really interested in setting the parent of this toggle using the member operation of the toggle. The whole point of using interfaces is that once you register, you implement this interface here and you got the operation, then you can talk to this object in the same way you talk to any other VL.Elementum. So you will use set parent of VL.Elementum. You don't need to even see the operation of this particular implementation of that interface. So that's also why really they're really internal. They're just local implementation of this global interface operation. In fact, if we go back there, here you see that they are not internal because these are really important. These are very interesting for us, no? And the VL.Elementa interface is just advanced, but it's not internal because we want to access all of them. And we will use all of these to talk generically to all the widgets. So this is the entry, really, the way that the perspective that we will use to look at the widgets is from the interface. We want to talk through this interface to all of them. Some of the widgets then might have specific operations because they are very specific. They have some features that are not part of, I don't know, but you need to consider that also the way this library was built. I was learning all these concepts by doing it. So at first, everything was part of the interface. So this concept of the components wasn't really there. And then at some point, I decided to commit to this entity component in a more profound way. So I started to dissolve the interface and move things to specific components. Yeah, I forgot what I wanted to say, but yeah, you should consider the history of this library because, and also probably we will see also today, that there are certain parts that must be written differently. I already know. They can be even cleaner than what they are. But the idea, I really try to move as much as possible towards the idea that the entity is very stupid and doesn't have nothing that is specific. Everything that is specific is just about the combination of these components, which is a dynamic thing. Okay, then this toggle automatically also gets the value property component, which is a utility that simply get the components and filter the one that interests us. Because we want to have these two operations to have the value output in the node, okay? So what you see here, this is the entity, the Elementum output. Oh, whoa, nice, nice, nice. Yes, tooltip crashes in visualizing the component, the Elementum. Okay. But the widget has other two outputs, which are value and observable value, because yeah, it's just the wrapper of this entity that we want to use as a toggle. But okay. Oh, but we're still doing something. Still loading. Okay. Then this node is the most important one, Elementa, which is the entry point to Elementa world. Because in the end, what we want is to have a renderer. Where is it?
You need to enable Skia, no?
Ah, true, it's a new patch. It's not enabled anymore by default, or it was never enabled.
2020.3 not.
Okay. Which makes sense. So the output is a layer, the Skia layer. We can plug there. And yeah, this is our toggle. Cool. So, well, let's try to replicate somehow the other patch. Let's say that we got two widgets there. They go together into a stack. It goes there. So let me change the settings here. So this is a very, very simple tree. And actually, let's add a bit of margin. And I will put stack Y. So I want to replicate exactly that graph that we had there. And here there will be color. Is it this one? No. I'm not using this library. I don't know the names. Okay. So this is really similar to what we had the other patch. We got three widgets, Elementum here. There are widgets, leaves. Then we've got stack, X, Y. They are also Elementa. So if I open one of them, this is just a wrapper process to expose differently some of the pins. But inside, again, another wrapper. Inside, they are, what they have in common is this layout, which is a widget itself. It implements Elementum, and as you see, it's very similar to the toggle because it simply has this operations from the interface and some components on create. And then again, we expose this component thing outside so that we can extend the feature of this. One thing to notice here, this layout entity as children. In fact, that's why we can connect multiple children, and this layout widget will take care of layouting them. So we have an input, which is a spread of Elementum. So Elementa is the plural in Latin. And this will go here to the layoutable parent. It's a component that takes care of layouting some children, but it's a component. So the layout mechanism happens through this component. And as you see, this is the path where we store the children. And here, where we implement the get components version, okay, operation, like you remember in the toggle, it was directly taken from here. But here we get the version of the components here, and we combine it with the version of the children. So because from here, we will have the components version of this part of the tree. So if something changes in the components of this layout node, then we will have a new version. But also if something changes somewhere up there in the tree, in the children, in the descendants, if some of the descendants change some components, then this will propagate downstream, and here we will have a new version. And that's important, because otherwise we wouldn't be able really to look, to traverse and look up the tree and check really till the very end if something changed or not. Yeah. And there is also this one actually, Sebastian, get graph version, which is about checking if something changed in the children structure in the graph, in the hierarchy. That follows the same mechanism. So if you plug a new child, then you got a new graph version, and so on. Or if some of your children, maybe there is another stack or another layout object there, and you plug some new child there, then this needs to be propagated downstream. So we got components version and graph version. In the toggle, there wasn't any graph version because it's supposed to be a leaf, and you don't need a graph version there because there's no child. It's a leaf. Okay, so this is the core of any of every layout node in Elementa. So the stack X, stack Y, columns, every layout nodes, each one of them do layout children differently, but internally they use the same widget, the same entity, which is this layout, and it's done in a way that you can wrap it, providing different layout techniques. So, and that's what really differentiates the different layouts objects. Okay, so all of these are widgets, each one of them implementing different components. They all go into the root. Let's have a look at the root. This is the Elementa root. This is something, this is one of the first things that will change, hopefully, in the future. because it's already not really nice. Since we got, this is the real root of Elementa, but then we got a sort of duplicated part here, because since we wanted to have overlay, then right now the overlay is basically another Elementa world that gets created and stays on top of the other. So, and it's quite limited as a mechanism, and that's why it will change in the future. And yeah, it should be done differently so that the Elementa world, the Elementa, can emit overlays internally, so you don't need to manually put it there. But anyway, so don't even consider this part for now. Let's just focus on this, which is the root and to Skia layer internal. So starting from the bottom, this one is really what allow us to draw into a Skia layer everything that is in Elementa. So it takes the layer from the Elementa manager, and we will see, and call notify, render over this layer. So this is really where we connect the Elementa world to the layer world. So let's go to the root of Elementa, which is this one. It's composed by this Elementa manager and a context. These operations set me are there because back then when I did this, there wasn't still this node, which basically provides yourself to the patch. So if you've got a class and you put this node inside, that node return a pointer to the class itself, to the instance. And it wasn't there, so I had to manually do this, implementing an operation. Let's say, for example, we get inside this Elementa manager, and there is an operation set me that I can call from outside. So from outside, I get the Elementa manager and I set it inside itself. And I do the same for the context and also for the widgets. You will see. Now it complains. So yes. Let's have a look. I should put some comments here. It's very easy in the end. This is the input of the Elementa node as well. It's just iElementum. So it's the first widget, that we connect the stack. We'll go inside here, Elementa. Then this is the input into the root through till the Elementa manager there. Boom. This is the input. So we store the root element, and as you see, we get the graph version. Okay, and this cache region checks for changes in the graph versioning system, and if we connect another widget as the root one, you also check that if it changes, then this basically we know that okay, something changed there in the graph, so the graph is dirty and we need to evaluate something. And what we do is getting the entry, the root element, and we traverse. This operation is this one, and we start from there. And what we do is, we use this expand region, which traverse the tree. So we are able to unfold our graph, what it does, because what I want is to get as an output all my widgets. So what I'm doing is I provide the root, the entry point, and then there I check if it's not the default Elementum, which means that maybe we didn't even connect anything. So if it's not a default, then we set the context that we will see. It's the context of Elementa. We set in cell. You see now that this is I.Elementum. These are I.Elementum operations. So we get the root, we set the context, we set itself into it. So, and then we get the children, because we are interested in doing this operation for every widget, for every entity of our system. So we set itself, then set the context, and then get the children. And for each of the children, we set the parent, because as we see in the I.Elementum interface, there is this operation which is me, so set myself. So I got a pointer to myself. And I've got here, I've got a pointer to my parent, okay, which is maybe the stack, for example, in this case. If the toggle has as a pointer to his parent, which is the stack where it's connected to. And then he's got also children here, but it's a different thing. So yeah, we take the root, set the context, set me, get the children, and for each children we set the root as their parent, so they have the pointer to it. And then we provide this spread of children as an output to this region, so that basically it then starts again, takes every element of this output, and again repeat this this operation, so that we traverse step by step. We go to the children, and we go on till we reach the leaves, where we won't have any child anymore. So there, this expand cycle will break, and what returns is the sequence of all the widgets that we basically output here.
So the expand node is not like an Elementa internal thing. It's like a VL.
No. It's a VL thing. Okay.
Okay.
And that's exactly what comes here. Is when something changes in the graph, we basically retrieve again all the children, all the widgets of our graph. Okay, and they are here. They are all available here. And then what we do, let's go on the other side here. We take them, and if the spread of widget changes, then for each one of them, we get the components. Okay. Yes, and for each component, we get each component, and get required processor is an operation of iComponent. So in every component, if we go to the interface, you see that this is the interface of the iComponent, and every component has a name, must provide a name, must provide a required processor. So I need this processor to take care of myself. So I provide here this information. And then Elementum, it's fundamental, because it's the pointer to the widget that hosts this component. So this component has this parent widget, but the component has a possibility to point to navigate to the host, the entity. Yeah, that's something else then. So we collect, so from every entity, from every widget, every Elementum, we get the components, and from every component we get the required processor, and if it's not null, then we add it okay, this code, the name of this required processor, we add it to this to these component processors. It should be component processors. I need to rename it. So this is an hash set. So when we add it, basically, if it's already there, it doesn't get added, which means that here we have the final list of all the required components, okay, from all the widgets of the graph, so that we can, we can do something. So this will be the list of all the component processors that we need to take care of their components. So that here, if this changes, we pass through this other part where we get this list of component processors, then we might consider also this part, which is root components. It means that not only the widgets can have components like tip component, I don't know. But also Elementa itself, this node, can have components, which are other kind of components. They are, why? Interesting. Okay.
You're paused, no?
No. Now it appears. It's weird.
Okay.
So they are iRoot component. It's another interface. And those components are maybe some components hosting settings for the processors. We'll see them later. But if you plug selectable component, selectable processor, settings, because you want to customize some properties of this selectable component processor, then this is a iRoot component, okay? So if you've got this and you connect it to the Elementa patch, it will reach, you see now that here you see that there are also the root components coming inside the Elementa manager, and they are here. So
just one question.
Yeah.
Like you can also provide settings per component, no? Rather than globally in the at root level.
Well, the components themselves are customizable.
Sure.
They provide like I don't know. We will see the transformation component. There you set certain properties of that instance of the component. Okay. Here is a bit different. Here for the root component, we are interested to maybe adjust the way the processor works over the components.
I see.
Okay, so it's a different level. So yes, so as we said, this part, if the graph changes, retrieve all the widgets. Then here we check. Okay, we collect all the components and get all the needed component processors, and then that's why also there is this union hash set here, because okay, these are all the component processors required by the components in the graph, but then we might have something here that we provide at the root level, some iRoot component. So when I plug iSelectable component, then I want to customize the component processor. Here I did it like that. I basically asked for the component processor. So yeah, this is the list of the component processor needed at this level that gets unified with the other ones asked required from the component sleeves. And then so this is the final list of component processors that we really need to instantiate. Yes. So because what I wanted to do is that, okay, imagine there are quite a lot of components already in Elementa. So, but I don't want to have the component processors always there in the root for no reason, because if I don't use certain components, I don't need the component processors. It would be just a waste of, of resources, of memory, we need to, we need the processor just if we have some components.
But here it already looks like you, well, like once you change one of the components in a graph, you're recomputing whole graph. Isn't it like this? So yeah, exactly here. So you're checking for any change in a graph. So for example, you can just make some change in a very fine leaf, and then this cache region will go for each of the components in there. So we'll go through whole the graph.
Yes. Yes. So here I'm basically checking for the component version. So I'm checking if you change something in the components version, you plug up a component there, then it goes through again the tree and collect again all the components. Okay. So yeah, you basically do this again for all of them. This was the first. Yeah, you might say that we could change it in a way that if something changes in that entity, then just that entity should take in and should consider for this operation. But I mean, this was the last attempt to really optimize a bit and react just on certain events. But yes, if the component version changes, then we go through all the widgets and check for the components. And then we collect the list of what's needed in terms of processors. We combine it with the root components that we are plugging to the root, to the Elementa node. And here, we simply, in the end, ask for an implementation of the component processor, because, as I said, what I wanted to do was to make sure that, okay, we got Elementa as a library, and as a user, I got my project. But let's say that in my project, I need a new component. And this new component has certain features and is meant to be to provide certain functionalities. So I would need a specific component processor that operates in a specific way over that component. So right now, without this system, the only way to make use of my component in Elementa would be to customize Elementa, to add this component processor to the system and hard code it in there. But since, but I wanted to avoid this so that it's very flexible and extendable. So right now there's this mechanism in which there's a factory. So when you, in your local project, in your personal project, your VL document, you can create your component, your class, implement the interface iComponent. You can create your component processor, that is iComponent processor interface, and then you can register those. Once they are registered, the Elementa root can already make use of them. So you can extend locally the features of the library because your component will be seen here and will ask for your component processor, and then through the factory we will collect it and and just create this component processor for that component. Then as you see, we set certain things into it, which is the Elementa manager itself and the context. And then here here I'm already collecting them, sorting them in certain ways, using some certain priorities. Oh, Jesus, it's so big. So, but this is the end. This is in the end the dictionary, and these are the final component processors, which are alive, and they are doing something. Okay, on the components. So whenever we change something up there, depending on what you do, we make sure that in the end we got all the component processor to operate on the component that we have up there. And there are some different operations, process notification, get layer, and then update. These two are in update. Yes. So that the same, we got this collection of component processors, and in the iComponent processor interface, there are some operations where we can set the priority for notifications so that we can organize them. When we process notification for the component processors, then we can say, okay, this component processor have as priority, so we compute it earlier, so we can organize them. And then we can, the same for the layer. We can say, okay, first draw this component processor output, and after and the other. So that's why there's order by, which takes care of taking our final list, a final spread of iComponent processor instances and ordering them using the notification priority or the layout priority, so that we can go through them. For each one of them, we get the layer. For each one of them, we process notification. And then, for each one of them, we just simply call the update function. So this is the root, the Elementa manager, sort of. Then there is the context, which is simply, it's a global context it's a class that we use to bring around all the relevant things, like mouse state, keyboard state, global state, which is an interaction state. We provide the Elementa manager itself, this one, the overlay, and we call notifications over the Elementa manager, but clients bounds. So it's a context that we provide to the system. Any question up here, up to here?
Oh, I have a question. For example, if we would like to integrate other kind of inputs instead of mouse and keyboard, that would be in the right spot to start, or?
Yes, indeed. Is that right? Because these are somehow the resources, no? This is keyboard state, and keyboard state get updated on notification, and notification get called in here, if you remember. Basically get the context set by clients bound, and then process notification on context. So we are back here. So if you add, I don't know, touch state, then you make sure that this touch gets computed, get processed here. So, but it's basically, it's where we put the devices and the resources of our system.
Mm-hmm.
So yeah, would be probably here.
But I see I have also to create a new process notification based on this kind of inputs, or this is a kind of generic thing that I can recycle? Or...
Here, what I did,
Mm-hmm.
I created my own keyboard state and mouse state because I wasn't convinced from there was many things missing, and yeah, I needed other things for easily operate on the widgets in the logic. So I created my own state, which gets computed once, and then the widgets up there can simply check the state of the device, no? Because the mouse state is just the mouse state. It's supposed really to be inside your mouse. No, it's one state. The mouse has one state. You can read it from anywhere. But what I really wanted, this probably was the difference. So I already wanted to have one state here and then update it on notification, and then just propagate and provide these states everywhere so that everyone can have a look at the current state of the mouse. So yeah, so that's where basically the state of our devices is in the context. So, and gets updated and get distributed upstream. Okay. Any other question?
I have other question. Maybe also Sebeskudi maybe needs also a bit of understanding on that. The hash sets, which is the benefit of using that instead of spreads or other kind of collections? Maybe it's a bit topic, but
yeah, hash set is really cool for certain things because yeah, it allows you to easily add a collection of unique elements, and you can have all the Boolean operations like union. It's really convenient when you don't need all the features of the spread, like get slice, or it's just a collection of unique elements, and yeah, and given this limit, this bounds, it provides a lot of very useful operation in it. So in this case, it's perfect. I instead of a hash set using a spread would mean that I need, for example, if I want to add something that I don't want to add it if it's already there. I need to check is it in there. If not, then add this, or these kind of things get away. Just use an hash set, and by the nature of the hash set itself, it's supposed that if you add something, it can be there just once. So you already have a unique, a list of unique objects in the collection.
Cool. This is why you're using union to collect all the...
Yeah, I just simply unify two hash set, and I got a new hash set, which is the combination of the two. And if they are overlapping elements, they don't get added together. We will just keep the first one, and this kind of stuff. It's very convenient in certain scenarios.
With, distinct and filtering through different parts of the tree, but it looks much convenient in this way.
It's really cool in certain scenarios.
And that's all from my side for the moment.
Okay. So, Jesus. Okay, I am in VL.Elementa document where my Elementa node is. this is the main VL document of the library. It has some dependency. Obviously, it's got the core as a dependency, then components, and I can show you maybe. Gosh, no. So this is the structure of our library. We've got outside here, we've got VL.Elementa that, and then we got these other documents. Recently for this version, we managed to split a lot the library. Before there was just probably, I don't know, 3 or 4 documents. The core was massive. So we managed to split in many different documents so that it becomes much easier to contribute, because we could, maybe some of you simply wants to add new layout nodes and can just create them and maybe work in a specific part of the library, and we reduce the amount of conflicts. That was the idea. So that, yeah, we got the core with some core features like the interfaces, components as well, all the interface and util nodes for the components, CSS, which is provides certain features for reading CSS files, getters, layouts nodes, they are collected here. So we split it, and then we have a widget folder containing all the widgets. Each widget is a separate document. So you can simply create a new document that refers certain documents of the library. And then, but there you can create your own widget, implementing the interfaces, whatever. And then eventually you can just ship, even just add it to the repository put it here. And then you will be basically, and then you need to, there is a widget, VL.Elementa widget document, in which is where it's a reference to all of the available widgets. So if you want to contribute another widget, you create the document for the widget, you put it into that folder, in the widget folder, and then in this document you reference it and automatically get basically added to the library. So yeah, this is the widget. Then layout. Again, I say that this layout node is probably just, if I'm correct, it's like for the widget. It's a document that refer to all the available layout nodes. And they are by themselves, as we saw, they are widgets, okay? And they are inside here. So in this document, we've got a stack and so on. And simply, they are just independent documents. You can create your own layout widget, put it here, and reference it into the layout nodes document. Same for components. We've got components here. There's nothing in there, just a reference to all the available components. And if we go into component folder, these are the components available. So
just one question about this one. Some components have their own VL documents and some other are in the VL, the common document. Is it because those don't have a processor or something like that?
I don't remember, honestly. No, it was just because I was lazy.
Okay.
And these were very simple. Maybe it's also because of that, because they weren't rich enough. I mean, they didn't need the component processor, so and they were quite very simple. So since we knew that we have them, so I just create a unique document. It's fine. Okay. And they are in this component common. But if we go to this one, eventually we see that we got these categories structured in a way that so that the nodes will pop up in the right place in the node browser. So when you implement your own component, this must be, you need to use basically this template. I think there is a template for this. Anyway, this structure is important so that in this category, we put the component itself, which is this one, guides, I component, and obviously this guy implement as a reference to the core, and to eventually other components, because maybe it makes use of them and other parts of the library. So yeah, this is the component, implementing I components and hosting some data. That's it. These are some other things used in the guides. And then we got the Elementa component processor for it, which is the guides component processor. If we get inside here, this will be our component processor. These are the operations from the interface, because this guy implement I component processor. And this part is where we do something, okay, with the components. And we will see how it works, this mechanism. Here it gets all the Elementa and filter and gets just the Elementa and the components that it cares for. And then, yeah, it simply operates in a very specific way. And yeah, and then there is a, as I said, there is an add component processor constructor, which is an operation to register these component processors so that they get automatically instantiated if needed. So this is the way you register. Once the component processor implements the right interface, you can then register it with this name, which will match obviously your required component name here in the component itself. So the component say, okay, I need the components processor, guides component processor, which will be what you register there with that name. Yeah, and then in this document, we have register services. This thing that allows you to register both, really. Yes. And then these are utilities, really. Nothing more than some utilities to retrieve the guideline components from a dictionary of components or directly from the Elementum. So I've got a toggle. I just simply want to get the guides components out of it, any widget, so I can use this utility to, instead of splitting get components and try get value or whatever from the dictionary, you have this utility node to simply get it. And this is very similar for all the others, like selectable. As you see, same structure. Here you got the component itself, very stupid component. Then the component processor, again, each one of them implements the I component processor interface. And then it's got this filter operation where it collects the components that you want to operate on. And then it's got its own specific process, okay? And they get registered. So that's it, basically. So if Yeah, this is the way you could add a new document with my COVID component, and it's document, separate document, and in there you got the component and component processor, and if you register properly, it will automatically be available in the library.
I have a question.
Yes.
Because I'm developing a component in this moment, and I wanted to know if the processor can the processor know about the component instance, a specific component instance in a patch? Can it talk to it?
Well, that's the first thing that is able to do it. Otherwise, it couldn't operate on it, no?
Yeah, but it can write to it also, no? On the component itself.
That's the whole point. That the components themselves, like the entity, the components themselves, in the end, this is also something that I embraced a bit later, also looking into Unity and ticketing components. In general, what this big architecture and system are, the direction they're following now is to remove all the processing from the components also, and the components are just also holding data. And, which means the component processor are really the place in which things happen computationally wise, and then everything they compute gets written back into the components that just hold the result of these, and locally there, so it's available. But as I said, if we go to component,
I get the point. It's like in the hovered component, like the component processor does its business, and then the specific hoverable node, the output true or false.
So this is the hoverable component processor. Here, he retrieve the component, okay?
Of course, yeah.
Okay, the hoverable, it's here. And then it does something and set, in the hoverable, set something, okay? So that in the end, the hoverable itself is just stupid. It does nothing. That the class itself is brutally simple. Just have a Boolean that hosts the result of the computation that happens in the component processor. Okay.
Okay, I see.
But that's the whole point. The component processor takes the components and so holds them here, and obviously can write into them because they're classes, can read and write from them. In this case, as you see, which is very similar to the example patch that we saw at the beginning, the hoverable component, for really make something meaningful out of this component, we also need a layoutable component, because we need to it test. So we need to know, okay, do you have a layout? I need to check a bound. So, and that's why there is this end here, because, okay, if you got hoverable component, it's fine, but you need also a layoutable component. Otherwise, I can't really do much for this component. If you also have that one, then, okay, I will have these two components here, and I can take the layoutable component and eventually it test it, and with some logic, then write the result into it. Okay, so and this is it's the same pattern that happens in every component processor. First there's this filter operation, and in fact, if we go back to our Elementa in the root Elementa manager, we are back here. Okay, if we see here in the update of the component processors, there is this filter. This is the first thing that we call somehow in update. When something changes, I don't even remember. Yeah, when something changes in the component processor and in the graph, then we call this operation, which is filter, which in every component processor is this first stage in which they get all the Elementa, all the components, and select just what's relevant for them so that they can then process using update or other operation, so that that they can process afterwards. Yes. Any other question? My God. Okay. So this is the library. There is also a solution, which is just a bunch of enumeration, really. There's nothing there. So everything is patched.
And test files also.
What?
The test files, which is important, like if you want to work on the help patches and things like that.
Yes, true. Yes. Yeah, the help patches are there. Here we saw, let's have a look at the core. In the core advanced, we have Elementum, which is our entity. We already saw this interface. It's got, let's have a look. Node context, which 1 hour ago I didn't even remember what was that, but it's the node context. It's the VL context of the instance, and I need it for basically. If you look into the toggle, I think, please, I don't know why it's complaining. Yeah, it's the node context which comes. It's the VL. Well, maybe Greg's, you can tell something about it, but it's a way to access the VL node itself. And I need it, for example, with the transformable component. You can plug the transformable component and move around your widgets in the UI, and then I think there's a toggle, or it's by default that the position that you choose, where you move the widget or your scale, position and size get written into the input pins of the widget. Okay, so that you don't need to retrieve them or write them somewhere. They are already written into the model of the patch. So if you stop and restart, your widget will be there because it's a value that gets set into the pins. And to do that, I needed the node context, which is a VL thing. Me is it's just the Elementum itself, the pointer to itself. Element is the name of the widget, because we wanted to label them. So this one, would be toggle, for example. It's a string, this element. Context, we saw it as is the access to all the devices and the current state of the system somehow. Components. This part is about the graph itself, the tree. So we got a pointer to the parent, and then we got the children and a graph version. Yes, then some utilities. This probably was just for the for the style. Okay, where am I? Core. So yeah, this was the interface. Then I got iRoot component. You saw them, the one that we plug directly into the Elementa node. overlay provider is the guy that provides that creates and manage the overlay. Some enumeration, stateful region, we'll see. The root, this is the root of Elementa. We saw it with context and Elementa Manager. And then to Skia. Layer internal, we saw it again. Then utils. This device is where I put my custom mouse state, keyboard state, and some stuff related to the devices. State, yeah, I don't know why it's here, but yeah, why not? It's the interface for the state machine that is used to define the logic of the widget. So that there's the behavior component that makes use of this interface. Yes, and then this is the core, and there's VL.Elementa component. So yeah, in the core there is also the iComponent interface, the iState component, which is a flag for certain kind of components, and then a bunch of utilities, no, just to add components to a spread, and build a dictionary. We saw this node, no, that takes the internal components and merge with the external components, and it's using this components dictionary from spread, which is this one, which takes care of merging, really, which we can't simply combine the internal with external, like, I don't know, overwrite eventually the internal one, because maybe we want to say, okay, this component, these internal components that we placed into our widget, we want to use that one, not another component. Yeah, it's really important to make use of that. So if we provide another instance of that component from outside, I won't use that because my internal one has the priority. That's why in the iComponent interface, there is replace internal. There's an operation. So when you write your own component, you can define, okay, if this gets, if you replace, if there is an internal one already, that gets replaced by the one that I provide outside. So you can somehow define which one is the priority, if the internal or the external. And these functionalities here make sure to merge correctly them. And you can, yes, what is that? You can register iComponent merger. Yes, because it's, let's say that attributable, okay, it's a component, attributable component. I put it inside my widget, like in the toggle, no? It was already, yes. Means that I can add attributes to it, and I mean like a string to object can be anything, no? And it's a dictionary, so which means that I'm providing some attributes on create, okay? But then if I provide an attributable component from outside the widget, if I plug it here, okay, what I want to do, I don't want to either keep this outside or keep the internal one. Maybe I'm interested in keep both the attributes, no? So I need a merger that really takes the attributes from the internal one and combine with the attributes outside, and so that it basically, yeah, just provide all the attributes from the two different components. So that's why it's, yeah, that's why we got okay, whatever. That's why for each component, we can also define a merger that, okay, for my attributes component, I've got a merger that knows, okay, with that component, I need to read the attributes and combine with the other attributes, okay? So I can register a specific way to merge components. And this functionality will take care of implementing that merger and providing the final dictionary of widgets. These are generic utils to collect the widgets, that the components from the dictionary of the components, directly from the Elementum by name, component name. Yes, utilities. And here also we have the iComponent processor interface, component processor model. My God, must be something. Yeah, it's just a flag. Okay. But yeah, this was, yeah, in the core VL.Elementa component. Then we've got an Elementa factory. Here is a dictionary of string to objects, so we can register, we can simply add stuff to it, and it will be available. Here also we have the component mergers, the component processor constructors. So when we register the component processors, they will come here. Yes, and then we get this get Elementa factory, which simply allows us to read this unique factory, which is a singleton. So it's a unique instance for the entire system. Utility, get Elementa, okay, whatever. The core. Let me talk about something very important as well. So we say that, oh, Jesus, the component, it's very important. This is the iComponent interface. Name, required processor, Elementum. This is the key, so that every component has so these are our
Nathan, can you stop sharing? Otherwise, we cannot see what you're drawing.
Yeah. Stop share. I wanted to make sure that. Do you see something? No, you see nothing, I guess. Anyway, let me try. So, do you see something? Toggle, component 1, component 2.
Yeah, more or less.
Is it visible?
With a bit of information.
There's no whiteboard in this app? No.
But so it's really important to think about the graph. I'm already talking about in the entity component architecture in the video, in the workshop. I already pointed out this thing, which is really important, so that the component, as we see in the patch, they have a pointer to the parent. Okay. So, and this is fundamental because in the component processor, if we look at the patch, I'm just collecting all the overable components for the overable component processor. I just need to get the component, really. I don't care about anything else. I can have the entire list of components in my system. I can filter out the component processor, the overable components, and then that's the minimum starting set. That's everything that I need really to start operating. Why? Because each component has a door to the graph, has a door to this to my tree of nodes, because it basically has a pointer to the parent, to the container entity, which is the toggle. And since we got this pointer, then from there we can go everywhere, because the entity as for example as the components. So from one component we can get the parent entity, and then get the components again, and maybe get other components. So each component through this pointer, through the Elementum pointer, can basically retrieve the siblings, his brothers, or can, for example, take the children of the entity of the Elementum. Maybe if it's a stack, for example, it will basically get some children from other Elementa. The component, okay, just jump over the Elementum, get the children, and then go to the first one and get the components. You know, it's very important to understand that with few operations, we are able to start at any points of our graph and navigate through it. So, that's why it's really, because you might think, okay, I got this component, which is the component of that widget. So in my component processor, it's important that maybe I need to provide both of them in order, to make something meaningful. But it's not true, because I just need to bring around this component, and from there, I can always know exactly where am I in the graph. So because I can check the entity, and then I can traverse, and I can, get the entity, get the parent, get the children. I can really navigate through the graph. And that's why then, let me go back here. And that's why there is this VL.Elementa query thing. Let's start with this. Maybe start with this. No, this one, whatever. So this query library set of nodes, it's a way to navigate through the graph and check for conditions of the graphs. I did it. I did it for. I started doing it when I worked on the style engine, because I wanted to replicate the CSS functionalities where you can define advanced rules. No, okay, if you are children of a child of this object which is in state over, I don't know, then this style rule applies to you. This kind of logic, which imply that you need to have an understanding of the graph. And that's why I started to create this library, which in the end, I realized that it's just a super powerful way to traverse, to navigate the graph, inspect the graph, and I can use it. And in fact, I'm using it everywhere now, not just for the style, but it's just a way to create conditions for anything. so okay, I get an elementum. I want to check if it's this element, basically, if it's this element, like if it's toggle, yeah, okay, it's a toggle. This is very stupid. Or I get this elementum. I want to see if it is in this state. Then I can, using this functionality, I get the components of type get is active, or iState component does something here, and then you check, okay, is it in state hovered? Yes. Or I can check, okay, this element has component, and here I define what kind of rule I want to have. These are very simple, but then you can get crazy and say, okay, as ancestor, given this elementum, I want to know. So I want to have a result which is true or false. I want to know if it's got a toggle as a descendant, as an ancestor. Okay, so if if he's got so if he's got a stack X as an ancestor, so my toggle is up there, and I want to check if somewhere down the graph, down the tree, there is, and I can do it because I can get parent from the widget, and I can repeat this. Well, there's a maximum 111, but yeah, I guess you won't have more than that, but we can push it a bit more. And you check, like, if you get the parent, because and you check, is it a default? If it's not a default, then you can invoke the ancestor selector function, which say, okay, in this case, it's a delegate, because I can say, okay, tell me if you got an ancestor that has certain feature. And that's why there's the invoke, because I can describe what kind of feature I want to have in the ancestor. If yes, then it breaks the loop and return me, okay, yeah, you got it. So this kind of way, this kind of conditional library is based on the fact that I can navigate in a complex way through the graph. So yeah, I can, from the entity, I can get the children, so I can go up into the graph, and I can get the parent and go down. Okay. So once the components can jump over the entity, then they are able to start from there, go to the entity, and then start navigation. So, and that's why now you can build a library like this with complex thing, like, okay, do you have a sibling? Which means, okay, tell me if you got a sibling which has a specific component in a certain state, for example. This kind of complex rules. Has a sibling before you or after you, this kind of stuff. If you are the first child of a widget which is in a certain state, which has a certain component, you can ask anything. Okay, that's basically just because you can. There's a nice, very simple operation to navigate through the graph and check things. Yeah, these, for example, are functionalities to get siblings, get children, get siblings with an invoke, with a delegate. So give me the siblings with certain properties that I describe into the delegate. Give me the descendants. Yeah. And this just to say that you can use this library from within the components. No, let's say that the component, there's a specific component that operates. Operates on certain other components, or I don't know, or certain widgets. So, and which are in a certain condition. But thanks to the fact that the component has the entry point to the graph, then it can use this condition, this query library, to eventually collect the relevant components, relevant entities to operate with. An example of these is the, I think, selectable. Don't remember. So selection check. Yeah, I don't remember now, but I'm using it. Somewhere over the rainbow. Okay. Utils. No, this must be just, yeah, bullshit. Okay. So that was the core. Getters, this is something that you did, Sebastian. Any over, I guess. Yeah.
Yeah.
Maybe the category is wrong. We need to change it.
Well.
Layout nodes, yeah. Okay. So, is there any question now?
I have a question, but more about the core, some parts of the core. But I don't know if you want to explore other parts, and maybe later we talk about that. Or...
No, you mean which part? The core, like, yeah, which part?
Inside the core, we have the advanced.
Yes.
I see. And inside advanced, we have device.
Yes.
And inside device, no. Yeah, inside device, we have this kind of mouse event kind and keyboard event kind. This is a kind of enumeration wrapper?
Yeah, there are enumerations.
Okay.
I just wanted, because inside the mouse state, my custom mouse state, there are operation to easily check certain things, like if it's in a certain state, the mouse, or. But for doing that, I wanted to have my own enumerations.
So
where
it would be nice if we are implementing other kind of inputs to have also these enumeration things, or because we are using that the whole time in all the operations. And does it make sense what I'm asking?
Well, they are here. You can make use of them.
Yeah,
mouse
but
event.
for example, if I want to implement a MIDI input, for example, I have to design also my enumerations, or in this context doesn't make any sense?
No. It's really up to you. For me, it was convenient to have this mouse event kind. If we look into the here. Enumeration, mouse event kind. I just wanted to have this enumeration with these entries. But it's just because I wanted to provide this this enumeration in this easy way to have this information, but it's really up to you, no? You don't need to create any enumeration or any. I guess they are not relevant in the MIDI. In yours.
I think MIDI can get advance of that also.
Well,
because I'm thinking how to implement that, so maybe it makes sense to have some enumerations or. the kind of device I'm using, because in MIDI we have a lot of more parameters to tweak.
I mean, enumerations are nice. Instead of using integers to choose between certain, when you build a library that needs to be accessible, needs to be readable, it's nice to have enumerations, and I would do it. Yeah, I would use them if that's something that you always need to change. If it's I don't know, it's a MIDI clock or a MIDI, I don't know. I think
just with the MIDI device names, it would be better if it works as enumerations.
But MIDI device name is something dynamic.
Yeah, I don't know if
that,
it
I guess no, because you can't generate them, right, on the fly. In that case, probably it would be a string.
Okay, so it makes sense. Yeah, it's more clear now.
Okay.
Yeah, let's see. I will give a try on that, and then I will come back with a bunch of questions.
Yeah.
Sure.
Okay, so so let's say, let me close up some stuff. Let's say that, well, in the end, I guess the first thing that you would like to know is how can I draw my own drawer for the toggle. Let's maybe you also have a look at these things that are a bit more practical, but they probably are relevant to also understand the mechanism of drawers of components. Sorry. So yeah, as I said, slider, side, like the toggle, some operations from the interface, some components, startup. One of them is default slider drawer. If you look at this component, it implements iComponent, but also iDrawer component. So it's a component, which means that, for simplicity, let's copy it. Oh. So I've got this patch. I can create a class that implements these two interfaces, that implements the interface from the operation from the interface, and then specifically that the drawer component simply have this get layer operation, which is basically we are supposed to patch our drawer. So let's say that instead of we kind of define a common language in the widgets, which is related to the style, so that there is a background element, a foreground, and a text. But yeah, nothing prevents us to draw anything really. If I put this one, I just use the global global rectangle. So yes, in this component, I get the elementum, and I can get global bounds out of it. And this get global bounds means that internally it's a utility node that will collect it, will retrieve the layout component and get the global bounds out of it. So you see, this this component is reading another component, getting the bounds, and these are this is the rectangle of where our object is, our widget is. Now I'm using it with a circle. So we are here. And if I connect custom slider, this is our component that we created here. And if I add it to the slider, boom. What? Wait. Ah, yes. Does he have it here? Okay. This was missing in this component. I need to flag it and say, okay, replace the internal eventually. As soon as I put it here, you see that it simply gets used instead of the internal default. So you see, it's very simple to create a drawer, simply creating, you can literally duplicate the internal one, and here you can patch your own. Yeah. Then obviously you can access every part of the widget, because a drawer, for example, the drawer for the slider needs to know the value of the slider. So it's obvious that we need to retrieve the value property component, get the value, get the minimum and the maximum from this, because this numeric value component, which holds the value of the slider, also has some features like min and max and default. So we can read everything from every other component and just draw accordingly. You know? In this case, there was a delegate, because depending on, you see, we retrieve also the orientable component, the get orientation component, orientable. So we know if the slider is vertical or horizontal. Then depending on that, which is different layout, to draw different the rectangles, but this is something specific to the slider. Yeah, so from this component, we are reading all the properties that we need. We are collecting the get widget properties of utility nodes that internally get the stylable component, set the local, the widget style properties that we want to use here locally. And then it basically provide all the style properties, the updated style properties, so that we can use them to draw. Yes. Any question about these? Okay. Yes, so it's quite trivial to implement your own drawer. There was also also a region, no, Sebastian?
Yeah. How was it drawable? No. Yeah.
Drawable.
If you go in the help patch, you can find it. I think it's drawable, no?
Yeah.
Okay.
So look, this is another very simple way to create your drawer, in which you don't even need to create a class where you implement the interface or whatever. This is a region. And you can simply use this region to draw something. So if you do get global bounds, I guess, from the Elementum version, is it? Yes, it's a stateful region. Then here is your bounds, and you can draw rectangle bounds, stroke, this is already a drawer. If I connect it here, this will be our drawer. So what we can do is, also we can get value property component, right? Like that, and in this way we are reading from the value property component, and then numeric value. This is the real component because oops. Get value. We need to infer the type because these, as we see here, value property component. How about we can, value T. Okay.
Yeah, value T versus value, like the boxing thing.
Yeah. So these will be, let's just do that. Boom. Okay, now we are telling him, okay, there is a value property component which has that type, and as you see, it's already in there. If I move the mouse, if I edit the slider, it's already changing. We are not seeing it, but it's there. So if I put another skier, if another object, which is a rectangle again. Yeah, let's just use the position. Left. I don't know. I'm just doing bullshit to show you whether we should remap correctly. This is the size. Anyway, just to say that this is another object now, another element that is connected to the value of that component of our entity, of the Elementum. So you can use this drawable component to just very simply patch your drawer. Yeah. So oh gosh, we need a week, not a day.
Is this region drawable state?
Yes. If I open it, the stateful region that uses this managed process, really cool nodes in VL, not really known, not that much known, but that allows you to create stateful regions with an update function. Just create an update. So by using these, yeah, this is the component, and yeah, you can basically have a stateful region here that will be called when we get layer. So just the drawing part basically will be patched in here with update. Okay. I think we can go through. Yes, let's maybe do that. Give me a second. I think we can go through some patches. The first sense of we can yeah, start from add patches. Widget action. I want to show you also the layout. No. So these are the widgets. They're quite simple, normal widgets. Then we got this layer elementum, which is a widget itself. No? If I go here, I see that it implements Elementum, has some components, can be extended using components, and have this drawable as a component, which means that I can put this layer elementum as a region in which I already patch the drawer here. Okay, this is what we see here. It's layer elementum, the moon, and yeah, as you see, as we did before, we get global bounds and we draw something in it. And then eventually, since here, if you click on the moon, it becomes red as well. because I implemented a very stupid, simple interaction with it, which happens through the layer, through the Skia layer system, because nothing prevents me to put a mouse and collect some informations out of the layer system. So, yeah, so I can also do that. Keep in mind that if I implement something like this, this is not really considered into the Elementa world, because it happens through the layer system directly through Skia. So it doesn't block notifications for the other widgets, for example. Then we got folder and panel objects. Folder is simply like a split, like a switch internally that enable or not this part of the graph, visualize or not the graph, and allow to interact with it or not. But still, it's in the patch here and get computed somehow. No? I mean, nothing really get computed there because we are not interacting with it, but it's still there. And the folder itself is a patch. The stack for the top, for the bottom here, and the title. And we switch depending on the value of the toggle. We switch between the stack version, all the elements, and simply the folder here, the title bar. The panel is a bit more complex, but it's similar. Well, no, it's not similar, but it's not similar because it's really another world. So if we go into this panel content, you will see that we've got an Elementa node inside here. So the panel is literally a window that opens a new space, a new Elementa space, completely independent from what's outside. So that's why I can put a camera and navigate into it, and it's a really completely different thing. And then there are these layoutable objects. They are simply shapes that can be layouted using the automatic layout system. All these nodes there. Okay, I guess we can go through some components to familiarize a bit with the mechanism behind. Tasks. Let's have a look at tasks, if they still work. Does it work?
There's no help patch for this one.
Well.
Well, there's a help patch, but it's cryptic a bit.
It's very cryptic.
And yeah, it's supposed to do something when you right-click the rectangle, no? Like you have this triggerer, where something looks like it's supposed to happen when you right-click it in the trigger region.
Yeah, mouse, trigger. If we press, interesting. Maybe it's not pressed left. Oh, weird. What if I do that? Yes, hopeful. Okay, it blocks the notification maybe. Okay, need to check this. So maybe it's not the right patch.
Well, maybe you can look at the styles. No?
Mm-hmm. Yes. So yeah, this is the local style component, which internally simply get a spread of style rules and provides basically a spread of style rules. Nothing really happens here because it will be the processor then that takes care of it. So once we plug this component here, we can add style rules to describe certain features for certain objects. So if we go, so let me open, let's go to the definition. Style, no, well, this is the style rule. Process. So this is the style component processor. It's similar to the others component processors. It filters out and collect just stylable components. And then for each, no, it simply takes, the first, the root, takes the root, the stylable component from the root and compute the style for it. And the style component is a bit different. This is something that I'd like to rewrite, for example, because it's not that stupid, the component itself. So this is the stylable component. And it's different from the other components because here the logic, the computation happens here, okay, the stylable components. So when I said in the root, we take the stylable component of the root element, we get the style sheet that we provide at the root, for example, and so that we compute the style for this widget, for the root widget, for this component, and this component then push his style to the upstream, because we want to have that cascade effect, where you compute the style here, then the stylable component of another widget, a child widget, takes the parent component, stylable component, and eventually modify the style with some local properties, and then it has its own local style, and then pass it over so that the children can do something with it. And that's why in this component we have compute style and set children style, which are exactly what I just said. Here we compute the local style, taking the parent style sheet and our custom style sheet with local properties, and we compute our style sheet, new style sheet. And then we set that style sheet into the children. And I guess this is what, yeah, at the very bottom in the component processor, we simply do these for the root element. We set the style sheet and compute. So we set the style sheet that we provide on the root, compute the style, and set the children style. Which means that, Jesus, we are back there. Oh, come on, I know we are here. Means that we take the stylable component of the root, compute the style, call this operation set children style, which itself, as you see, you basically call again the children, compute the style of the children, and call set children style over the children. So it's like it's a chain reaction. They start from the root, where I simply compute the style for the first object, and then I set that style on the children. By setting the style on the children, I trigger the computation of the style for the children that themselves do the same operation. So this mechanism propagate upstream. When I compute and set the style for the first component, then this triggers the computation of the style for the entire graph for the children of this object. So this is a bit different. And that this is something that still I didn't really solve into a more simpler approach. And here, ideally, you wouldn't have anything of this. You would have just this style sheet property here. And all the operations, all the logic would be implemented in the processor. So I think it's not even a good example, this one. Select drag reference. No, what is that? Let's try this one. Come on. Okay, we are here. Let's have a look at this selectable component. So I disconnected and the toggle is not reacting anymore. And the selectable component, we already saw it. It's very simple. Just hold that information if this is selected or not here. And then there are some custom custom settings that we can set. No? If we can decide in runtime if this is selectable or not. So if I do these, probably you won't get selected anyhow. Or I can define more more information, like more settings, like now it's not settable. Yeah, start selection means that I can decide if I can start. Look, for example, if I do it on this one, it will be simpler. Okay, now the stylable object is selectable, but if it choose that is not, then it doesn't get selected. No, but it's over. Okay, whatever. Yeah, if I enable the start selection, means that no matter what, if I'm over it and I start dragging, I will start to select. If not, then nothing will happen. Or custom start selection rule. Look, if I say, okay, when you are over this object, you can start a selection, okay? And this is the selection rule. This is the custom start selection function. So you will start the selection on there if this condition is true. And look, you got I.Elementum, I.Notification. It means that you have everything, because if you go in I.Elementum, you can get context out of it, because every Elementum has the context. And from the context, you can get, I don't know, keyboard state. You can get check gesture kind. No, this is okay. That one. Let's take this one. Mouse state. So let's say that position in the word, and we say that vector split. So if this is bigger than I don't know, something, how much is it? So I define a validation rule, okay? Now I'm starting the selection, but nothing happens because the selection doesn't start, because I'm providing a custom starting function, which has, is a condition. So if I'm with the mouse above this position, which will be, I don't know, here it's for sure over above it, then I can, the condition is true and I can start selecting. And remember that in here you can use the query operations, like as sibling, okay, condition. Yes, let's do that as a region. Look, this is one of the, I can connect it directly there. This is one of the query operations, which takes a widget, an Elementum, and returns me true or not. So I can design here a condition, and these functions specifically say, okay, is true, it will return true if the input widget has a sibling which, I don't know, has component as component. Let's just do that for now. What can we have? ID. So let's say that this toggle has this ID component. ID component, yeah, we can just assign an ID. And we say, okay, as component with component selector even. So I'm saying the condition will be true only if my input element has a sibling which has a component I don't know where was it? Component. Well, yes, let's do that. Get well, in this case, it's simple. We can do as ID. Yes, there's already a function for that. So, so we can say as ID, true. Okay. So my rule now is that you will be able to start the selection when you are over this object only if there is a sibling of this object which has a component. Actually, if you have a sibling which has ID yo, and as ID, if I go to it, what it does is simply takes the component, gets the ID component, and check its value with the one that I provide outside. So you can do this in there, or you can simply use this operation that does for you. So now I will be able to, come on. I missed something.
The ID assigned to another component, to another widget, isn't it?
What is, sorry?
You set it the ID to toggle, but this is a round rectangle.
No. That was the. Wait, if I connect this one, start. Okay. What am I missing? Sibling. Well, it should work. Let me check. As component condition, just that. Let's do ID. So neither that. What's going on?
Can you try with taskable or no taggable? Because I remember I had some weird situations using ID, and when I moved to taggable,
could be. No, it's could be. It could be because probably we didn't delete, but I don't remember. Yeah, probably ID it's not used anymore. I think. Wait. As taggable. I have no clue. It's weird. Let's try to do that. Okay, wait. And if we do these, boom. So just to understand where's the issue. Okay. So and yeah, okay. So probably this thing here, I need to check. There's some issue somewhere. As sibling. Accept item. I don't know. But yeah, the thing is that here you can define a specific rule for the selection to start. And this is, you can build another custom filter rule to filter objects. Let's try, for example, to say, so these are custom filter rule means that these are the object that gets selected that are inside this rectangle, rectangle selection. So potentially they get selected. And then here I can filter them. So if you have, if this has tag yo2, then Jesus Christ. I need to give this tag. Well, I need to check something is broken. Apparently. Anyway, this was just to show you that you will find a lot of these delegates. And also other parts like transformable component, where you set the transformation. Even there you can customize certain rules, and in those rules you can describe, you can create complex validation rules using the same library that is supposed to work. So yeah, but yeah, this was just to say that, so that this selectable component has the main data that we want to store in the end, if it's selected or not. And then there are some settings that we will control from outside to, yeah, that will be used in the component processor. So if we go the selectable component processor, so if we go here, again, this is the shared operations from the interface. This is the filter operation where we collect all the components. And then this is where we operate with it. So what it does in process notification, the component processor, it goes, yeah, it's got these selectables, spread of components, and these are the selected ones. And so this is a property here in the selectable component. What it does, depending on the rules now that you have here, there are certain logic to filter out, to select the widgets, but in general, we use the selectables for each of the components that we have, selectable component. yeah, we intersect with, yes, there's some logic, but in the end, it's all about writing in the selectable components, writing the selected information. So every component processor has a different patch, but in the end, what it does, it implements a logic that computes something and write back into the components. Here you see them where we write back into them, and then nothing prevents you to store data in the component processor, and that's why there's a way from the Elementa node to access the component processor, because they hold many information. Here, for example, we can retrieve directly here the selected widgets from down there. So if we go back to the patch, yeah, in this case, this is where you, no. Get Elementa man. Yeah, okay. For example, this utility node here just does that. Takes the Elementa manager, takes the component processor and select the selectable component processor, just retrieve that. And from the selectable component processor, get the selected Elementa. Yeah. So basically read back this pad, this field. So you can hold data into your component processor. No, it can be very rich. You can some of the data then you write back into the component, but nothing prevents you to keep it also here.
Can you show that a little bit, just like writing back to the component itself? Yeah. Okay.
Yeah.
No, because in the component I'm doing this, and I was doing it on updates, but it's not really optimized. So well,
it depends from what kind of processor is it. Like, well, if you go in the Elementa, manager, as you see, these are all our component processors in the end.
Yeah.
And then we call different operations on them. The selectable component processor, for example, operates on notification because it makes sense. It's something that is related to the interaction. No? So it must update itself, and compute is processed during the interaction, the notification. But the drawable component processor, for example, that collects the drawable components and draw everything, just gets called by the layer, by the SCIA layer system on get layer. And then you might have something else, like the filter operation, where the component processor filter out the relevant components. Oh, shut up. This is on update, because it's on update where we change the patch, where we change the graph, where we need eventually to recompute, recollect the relevant component. So that's why this is on update, because that's where we change. This is the operation in which we change the graph. So, but I don't know what kind of component you were working on.
It's for the scrollable value component.
That's indeed something related to the interaction. So I would, I would put.
I wanted to implement this feature that if you connect the component to a node that has not implemented it, you use the warn node, and the node says like the orange warning, and says the component it's not implemented for this widget yet. See what I mean? Like if you connect the scrollable value to a bang, it doesn't make sense. So the user has to know that it's not right what you are doing. So I used from the component processor, I have this field in the component that says not implemented. And if I cannot find the delegate for this widget, it's set to true, goes back, and then it turns on the warn node, and the component turns orange.
Yeah, it's perfect, no?
Yeah, but it's because I'm not really sure. Like in the component, I have to enable the update operation on the component. Otherwise, it doesn't seem to be working. But then I got this update pin on the component, which doesn't make sense. So yeah.
Do you want to share the screen?
Oh yeah, why not? Okay. I think I have to restart V4 for this. Oh. I don't know if you have the... Do you see my screen right now?
No.
Oh.
Yeah, it's something.
Okay, it's blinking. Okay.
Whoa.
Well, it's a bit weird. Hold on. Okay, you get it now?
No, there's an issue with the...
Well, there's an issue. Okay. Never mind. I have no idea why it's not working, but...
I see something now. Oh, we lost him. Okay.
Anyway.
Okay.
Okay, I think it crashed my GPU.
Okay.
Perfect.
But anyway, so you don't, I mean, I don't know what's, yeah, I should see the component.
Yeah.
I mean, you don't necessarily need to put anything in update of the component. It's just your component processor that can call an operation over it.
Yeah, it does it. Like if I do it like that, if I don't use update, it's okay. But it's just true for one frame, basically, because I have this Boolean pad that says not implemented. And in the component processor, if I don't find the delegate, I say I set it to true. Then it turns true for one frame. And so the warning disappears. So this is what I don't really get, but...
Why? It's true for just one frame.
I don't know. That's why I don't understand.
No,
But
if you write into that property in that frame, then you don't write it anymore, and that property stays to the value that you...
that's why I expected.
Yeah, make sure that you are not writing also locally there. So make sure that operation is not enabled as a fragment of your node.
No, it's not. It's not.
Well, then either there's something else that write into it that use this operation, or I don't know.
Yeah, me neither. Anyway, I'll try to debug it.
Okay. Okay, so is it bit clear now the mechanism of the components, like the fact that you define a component and then you operate through the component processor? Is it something clear how it works now? Because that's the most relevant thing.
I mean, it's clear, but I mean, maybe we need to use it more often. So.
I think it became clear for me when I actually patched a component from scratch.
Yeah.
Like this whole factory thing, because before I wanted to work on a component processor and I was looking at the patch at the like a node for the component processor and I couldn't find it anywhere. I just like where is the node? And actually the node is nowhere. It's just instantiated by the factory, but yeah, you have to know it.
I guess that's why also I split it and modularized and granularized this much, because you can simply duplicate a document of the components there and modify it, and create your own component with your own component processor that gets registered. And yeah, so that could be a good way to start creating your own components and component processors. Yep. Just start from what is there already. hoverable component. You see, it's so stupid as well. The hoverable component, and use hoverable component processor. So if we go to the hoverable component processor, here it's even simpler. Simply, still we have the filter operation that filter the components if they have the hoverable component and the layoutable component. And then for each one of these components, yeah, we saw it, no? And just hit test, checking for certain condition, if it's occluded or not, if it's the first hovered. So yeah, certain conditions, more advanced conditions, and then set back the result into the hoverable component. Then again, this is an operation that is part of the hoverable component processor specifically, so that you can, from here, you can, if you have the hoverable component processor, you can get this information if there's any widget hovered. But because locally in the component processor, we are doing everything there, and so we must have that information there. So yeah, I guess this is what you added, right?
Yeah, this is the any hovered function.
Yeah, so you're simply checking the count, I guess, and
yeah, no,
filtering
actually,
for the layout.
Yeah, like if you want to consider the layout operators or not.
Mm-hmm.
This is just yeah, this is just the if region what it's doing.
Yeah, in theory, for example, just to make an example, here, these are the taggables, and you want to filter by the layout. You could say, but this is fine, just to be more connected to the library. If you get parent, no, shut up, no, get Elementum. A component. So from the component, we get all the components. We get the Elementum and say as tag, okay. And this way, we say, okay, if the component that you are, if you, the widget you're part of has tag layout, then don't consider it. Okay. Just to use the library. Okay. So I guess, yeah, the best would be if you start, when you start to create a component, which can be very, very simple, really. But just to get familiar with the mechanism. Yeah. And then you can end up using this, having a look at this component, which is probably together with the style, is the most complex one. It's this movable thing, which is interesting because here you really see how this mechanism works of the components, where how they interact with each other because you see that there are two different components here. One is transformation, one is guides. And guides is to basically provide some guidelines. No? Let's say you've got a widget, this slider 2D. Okay, this is the widget we are looking at. Is selectable and have these guides. This guides component allows you to expose to the system certain guides. So you can basically, use the widget bounds here to generate some guidelines. And then so that the other widget can react to it. So the transformation component processor will take care of, so first the guides component processor, if we look at it, basically what it does is, it gets the guides component and compute the guidelines, basically, filter out all the guidelines and create this local. This is something that is stored locally in the component processor. So this component processor takes all the guidelines and computes everything and processes the guidelines for the widget. So it takes the guideline, takes the bound, the global bounds from the reactable component, and depending on the settings of the guides component, compute the guides and and add the guides to a list of them. Okay, and this final list of available guides are, and the guides is not just a number, it's a bit more than that, because you got a position, a label, and a pointer to the elementum, so that you create this list, collection of available guidelines, but then each one of them is intelligent, it's richer, so that when you snap, you can filter out guidelines depending on certain condition that you describe. So you say, okay, I want to snap just to the guidelines that that has this tag, for example, or you can. That's why it's a complex thing, the guide, because it needs to be to host richer informations. But this is interesting to show that this guides component processor take all the guides components and in the end compute some information that's stored locally in itself. And then also as this part which takes care of drawing something. Then if we go back to here, the transformation component instead, which is the most complex one, I would say. What it does, if the snapping, because you see now here that there is also, you can add this snapping node where you define, okay, which part of my widget is snapping. So which part, if there are guidelines, or if there are, which part of myself is snapping to. So the rotary or the slider, for example, I can now is, Jesus, it's not working anymore. Come on. Yeah. Now every part of the slider, also the center, is snapping, but if I disable the center off, right, middle off, then if I move it, then the center won't snap anymore. Okay, so going back there, this transformation component processor, what it does, it also retrieve the guide component processor, because what it means that the guide component processor compute the available guidelines, and then this component processor take, if we look here, you see, the snapper provider. So this component processor reads from the guide processor and provides the snapper points. So just to show you that we saw that this is a very parallel system in which you have components and component processor that operates with them, but not only the component processor can read the overable component and make use also of the layoutable component, no? But also the component processor can talk each other, can read, can check the state of the other component processors, like in this case. So because they are registered, they are part of the same thing, and they have crucial thing. They have as an input, they have themselves. So each component processor can access the others. So, and in this way, you can start building complex logics, no, and dependencies between these engines. Yes. What would you like to see more? I know there's a lot. I mean, the layouting, for example.
Mm-hmm.
Is it something that you're interested to, or I don't know? Because so let's take this one. Just to give you an idea of the stack of the layout nodes inside. As I said, they are, yeah, I don't know, I'm jumping here and there because there's so many things that obviously one session is not enough. But I'll just go through something that could be interesting if you want to start extending the library, you know?
I think like creating, if people want to, the most basic way to contribute would be like creating widgets, I would say.
Yes.
And widgets, but there's already like a page on the GitHub repo that explains not everything, but most of it, I would say.
Well, but that's a good point. Anyway, now we talked about the architecture, and if we take it seriously, what we say, we can say that if you want to implement your own widget, that's nothing more than creating a class which implements VL.Elementa, which you can duplicate the toggle briefly. So that it implements certain common interfaces, common operations that gets used by the system. And then your widget in the end consists in a series of components. Some of them are already there. Some of them you might want to create by yourself because they are very specific and they don't exist. So in the end, your very custom widget is made of this patch, which you copy, and then you say, okay, I will provide, instead of this, I will provide my own drawer. Instead of the default toggle drawer, I will provide my own drawer. I will have my behavior, we could eventually have a look at this, at the behavior thing. I don't need attributable component. Okay, it's nothing that interests me. I will use layoutable leaf because it's fine for me to provide position size to my widget so that it can be used, can be layouted, and can be manipulated in that way. I think it must be overable and has a value. Maybe it doesn't even have a value. It's just, I don't know, something that doesn't have a value. So really, it's using the components that you then build your widget, and the rest is the same. Obviously, if you don't have a value component, you don't need this part. But this part and this part are the I.Elementum interface, say, no? So in the end, your custom widget is just a list of components, and yeah, the name of your components here. But that's it, really. That's why I want to focus on the components and the way you can implement your components. And like, as we saw, that the drawable component is trivial to implement. Yeah, it's just the logic. Maybe we could have a look at the logic, because if I think of a custom widget, it's just what you see and how you interact with it somehow. So if we go back, all the behavior of the widget happens inside this behavior component. The behavior component is a state machine. So you use this state pattern. So it's basically composed by this part of the patch. So we think of the state of the components as interaction state. So well, maybe this is not a good example. Let's talk about the slider, which is more interesting on this level, because the slider, okay, we know how to draw it, but how we edit the value of the slider. And the way we do it is we program different states, different interaction states. There is the idle state, and each of these states is a class, okay, that implements iState interface. There is an iState, there's an idle state, which is the state in which the layer stay normally. That implements also idle state, because so it's this particular state which needs to be recognized. Yes, and in this case, okay, so once you put here that the behavior component, you need to provide through these two regions, you need to provide, okay, what's the idle state? Because when it gets created, the idle state will be created as the starting state of the interaction. So, and that's why we put here the create of this slider idle state. So this will be the first state that gets instantiated and as a starting interaction state. Then we have focus state region here, because focused is it's a specific, it's generic condition that we might want to interact. It's a specific way we would like to interact with the widget. So it's a generic way to talk to the widget also. No? So let's say that we want to tab through the widget. We want to focus on different widgets. So we need to know, okay, if I tab to another widget, I need to know, okay, there I'm defining a list, a series of interaction states. Which one is the focus state that I should point to? And that's why here we are providing this this region. We are saying, okay, if you want to call the focus state from somewhere outside the widget, then you know that you will come to this state we define here, which is the typing state in this case. But apart from that, as you see here, so we are just saying these are our two specific cases. This is the starting point, let's say, and this is the focus of our widget, of our interaction. Except for that, we are not really defining anything about the logic and this state management. And neither inside the behavior, there's nothing really that describe how you interact with this widget, or this is just holding the interaction state and allows you to check for, if is it idle. It's a generic component. What really matters in the end is how you build the interaction state for this widget. Like if we go into the slider idle state, as I said, it implements state and idle state. And here we got a name, and on create, we basically from the Elementum, we collect certain things that we might be interested in working with. And then what's really relevant, obviously, is the process notification operation. So where we interact with the state. And in here, for example, we have the context, so we can get the mouse and check everything, because we are on create, we are also retrieving the overable component, so that we can simply we hold the overable component, so we always can ask if it's hit or not, hit test or not. And then we simply design our logic here. So if hit test is true and double click left of the mouse, double click is true, so we double click over the object, then we go to state. This is a region to simply go to a certain state, and we provide the information here to pass this information to the new state. So we create, so each interaction state is able to create a new state and set that state into itself, into the state machine. Okay, so each one of them kill itself, creating a new state that replace the current one. In this case, when we double click on it and it's over, we create a typing state that would, so we enter in that state really, and we will find ourselves here now, which obviously matches, somehow implements the same interface. There is also updatable state, because in here we want not only we want to interact in notification, but also we might want to have to update something in the main loop constantly, not only on notification. So that's why there is this interface, so that from outside in the behavior here we can get the live state, the active state, and if it's if we cast it, if it's an updatable state, just we update it. But going back here, as you see, it's quite simple. On notification, on process notification, we do something, which in this case is we cast the notification. We use the typewriter to edit the text, and eventually, this was to tab through the I don't know. It's just a logic of this state that eventually, if we press, look, there's a go-to state here. So if get mouse event kind, so if it's mouse down or mouse up or double click or is lost and it test is not true. So if we are outside the widget and we click whatever, or keyboard state, check gesture. So if we press return or tab, if one of these conditions is true, then go to state, idle state. So if that condition is true, then we basically navigate again, we create another, the new idle state, we navigate to it, and together we eventually write what we were typing into the value property component of this widget. Okay. So, but again, from this interaction state, remember you always have access to everything, because in all this logic, as you get on create is Elementum. So you get the entry point to the Elementum itself, which means you get entry point to through everything in Elementa, to the local widget, to his component, to his children, his parents, and so nothing prevents you to do everything. You could create a state in which you enter into that state, interaction state of the widget, and you change the value of another widget. I don't know. You can do everything because you have access. You have to the entire graph, or yeah, it's up to you really. So this is the mechanism in which the dragging state is the same. On create, just optimization. For optimization reason, we collect certain things that we are interested into and we need during the logic and the interaction. And then here, yeah, we simply implement our logic, getting the position of the mouse. This is some yeah, I generalize a bit the way you interact with things. So if you want to create your own widget which has some dragging behavior in it, you should probably have a look at this generalization, because you might just use these and tweaking them a bit different. But again, this is just a logic to, in the end, write the value of the numeric value property of the widget that we collected on create. Okay, somewhere over the rainbow. Yes. So we collected the value property component on create. So we got this, and from this state, interaction state, any point we want, we can write into it. That's how it works. So we got a component that's writing into another component value. So this interactivity in this, it's easy. And you can have as many states as you want. Just each one of them, like the idle state, for example, go to state with this condition, but then you can go to another state, which is the dragging one. If it test, the mouse is down, and while it's down and is not moving, okay, sorry, when it's down and you start to move, then you go to state, or you can navigate from here, you can navigate to any other number of states. So this is this state machine pattern, so that you can patch your logic. So already with this component here and the default, this behavior component, numeric value, which can be anything, is generic. Also, this thing is numeric, means that yeah, you can have any sort of vector. Yeah, it's just a value. So with this one, so, which is the state, the value of the widget, the interaction behavior that you want to have, and a way to draw it. That's it. You got a widget, and the rest is, yeah, obviously you need a layoutable, because to interact with it, probably you need it to be somewhere and maybe organized and nested into other structures. So, but with few of them already, yeah, you don't need to rewrite anything here. You would just maybe write your own your own drawer and your own logic, but the rest is the same, I would say. Is it clear?
Yes.
And yeah, you just need to get familiar with them. And I tried to generalize things. So probably many components, you can just use many components as they are in different scenarios. And so it shouldn't be hard to implement your own widget. And then if you need specific things, you can start creating custom component processors. But I guess it's all about that. Yeah, it's just entity components. So there's no more than that. And yes, and then there are some more advanced things like the tasks and this kind of stuff. Yeah, this still also needs to be polished, because it was done a bit in a rush. And so some things are like, yeah, a bit hacky. So,
Cool.
Yeah.
Thank you.
So, yeah, I think we could wrap it up here.
Mm-hmm.
And I don't know, how do you feel about it? Alex.
It's great.
How do you feel about it? I mean, is it somehow, did you get something more? I mean, is it clear now a bit more, like how to interact with the library?
Yeah, definitely it is.
Okay. Is it too confusing? Or
In some points, but not too much. I mean, it would be easier probably to get Monty from now on to like go through the patches.
yeah, I think, yeah, that's the next thing, probably, to even these concepts that we analyzed, we see that they can embody in different ways. You can have a very basic, stupid component, or a very complex one, like the transformation component. But in the end, the principle behind is always the same. So maybe now that you've got the picture of the architecture and the mechanism behind it, then you can go through the patches again and maybe start from simple components and recognize the patterns and the architecture.
Yeah, but what's important now for me is I got kind of an idea how can I customize the library for some specific like bigger projects, like to. So it's super cool with this library that you can build a simple UIs just by patching it as it is, and I don't know, implemented different styles and some little specific widgets. But sometimes when you have like a, I don't know, so for example, now I want to build some kind of another version of this Mbox mixer, where we can run the different scenes in parallel and mix them up and so on. And one of the bigger tasks of whole idea is actually to build a UI to control it. And now I see great possibilities how to deeply integrate two things together.
Indeed.
And yeah, make it dynamic and nice.
Yeah, I think that, yeah, now that you got a bit of overview, if you start to then, with a different eye, going through the library, you will find even more flexibility in some parts, like the layer element in itself is so cool that you can just put something there. We could be just an image, like a video, like a simple thing there, no? But still that can be integrated and layouted. So yeah, I mean, you can just explore a bit more with this different perspective.
Yeah, but going back to like initial topic, how to contribute to this library, like I don't see so far like lots of things which I could contribute, like essential things. But what I'm curious is how to make the library itself working a bit faster, and like what was you showing at the beginning, like this root and managers. I believe that there is kind of a bottleneck with building a graph. When you like make just a little change, which might not affect like the whole tree, but just little part of it, you still get recomputing a whole graph. And I think it's kind of one of the things which make it slow.
Yeah, for sure. I mean, there is room for optimization. This was just the first step by part, because this state was quite recent. Before it wasn't like that. It wasn't that dynamic. The route wasn't that. So from now on, then it's up to us to optimize a bit, and that would be cool as well, to define different logics to update parts of the graph and not the entire graph, depending.
And what's your plan now? How to go on with it?
It's in your hands, guys.
Okay.
I'm leaving. Ciao. No, my plan is, well, ideally, to have more people in the project, and it would be cool. I mean, if you are interested in this, in optimization, I would be so happy. And if you get your hands dirty into the root of Elementa and try certain things, while maybe I implement other drawers or other widgets. No, if just having more people working at different levels, that's a dream, no? So that we can.
Yeah, but that would require some like proper collaboration. Because like when someone changing something in the manager, it kind of getting hard to track all the changes for others, and
but that's, I mean, this is the nature of open source projects. I mean, we got a open source repository, and everyone interested. I guess we need to follow the guidelines of how this kind of contributions. There will be pull requests, and I guess we are not thousands of people. We can handle that. And if you create your own, if you do your own research, and optimization, then we can validate it all together, and if we can just merge it back. If there are breaking changes, we need to be aware of that, and eventually. So I mean, this is common way of working, cooperating, I guess, and it's already what we are doing, because Sebastian has his own branch and maybe creating the help patches and then pushing the help patches, for example. So I think that there's nothing that really stops in collaborating this way. So I don't know. Also, from the fact that we split the library in many documents to prevent the conflicts, and so yeah.
Yeah, Arian, what would you say?
Me?
Yeah.
That I'm really happy right now with Elementa state, because I'm using Elementa since pretty much since the beginning, and I saw for example, the performance improvement. So right now you can handle a lot of UI elements without too much problems, but there is still some room for improvement. For example, the way we handle the panels and the way we handle the folders and tabs should be a bit more intelligent. So every time we close a folder, for example, all the elements inside the folder should be not evaluated, or these kind of little things that you see only when you are using the.
Let's consider another thing that by the word shouldn't be evaluated means that we're talking about the update of the node, just that. Because if they are not connected, we don't interact with them. And so, and on this was just to say that still I didn't update to the latest VL version. So, you know that with Stride now, we got this feature of the fragments, so that now the update operation of the widget patch is where you connect all the position, size, and whatever. And they are all on the same operation, update. Okay, but the next thing that I will do is granularize this and split into custom operations. So in the end, your widget will have all grayed out pins. And just if you connect something, you write the position to it. And if you disconnect, you're not using it anymore. So this would make the update operation either completely dissolve the update operation of the widget, or for sure make it more light. So even on that side, it would improve a lot. Just on that side, because in theory, if you got a widget hanging there and it's not doing nothing because we are not interacting with it, it should be super light. No, it should be basically nothing. That's the goal, and I think we are getting there now with this new feature. And I like to implement it and test it. But yeah, and then there's the logic under the hood. Then the way in the root we update the graph. Yeah, the layout system could be also optimized, because now if something changes in one part of the layout, the entire layout gets recomputed. Because it's an advanced layout system, because it's a bidirectional dependency. So we should refine the logic in order to really check, okay, if I change something here, if it's not influencing the rest of the graph of the layout, the rest should stay the same and just update the part. But it's not, there are a lot of things to consider. But yeah, I think there are so many things that we can do, and each one can contribute in small things. And then, okay, now we are 4 people here, but I guess that many will just update with the recording. It's still recording, Jesus. Yes. Okay. And yeah, that's it. I don't know. What shall we do? Nothing.
Just have dinner and
Yes, just go home.
it was very, very illustrative, and thank you very much for that, because right now we are getting only guidelines from users, not really from the developers. So I think this is very, very important to have these kind of meetings and to have this kind of to do the things in the same way all together, not just one in one way and the other in other. And when we collide, it's
always a pain.
Yeah.
When we collide. Cool. Okay. Well, I guess that we will continue to talk in the Elementa channel. And let's see, maybe we can find subtopics for other talks where we get more specific. Yes, and ideally it would be nice. This is, I think, that in the end, the outcome of this process maybe could also be a series of videos where there's a video where, okay, make your own widget. But very specific to that, or make your own processor, component processor component, or these very dense, focused videos, so that maybe it's even more accessible than this 5 hours talk. So
Thanks, Nathan.
Yes.
Yeah, thank you.
So it was a pleasure. And speak soon.
Soon.
Great.
Take care, guys.
Ciao.
Ciao.